Let's check who all has joined. Okay, I'm the only one. I'll just wait. Hi all.
Hello everyone.
Hi Rohi. Hi Abhay.
Hi, Bhavat.
I see Sarangs has joined in as well. Let's give him some time. Hi Sarangs, can you hear me?
Yes, I can. Can you hear me?
Yes, I can hear you. Let me admit Rahul.
Okay, but I have joined on device. I was somehow not able to join via laptop.
Okay. Does that mean you're not able to see my screen?
So, no, I can see your screen. That should not be an issue. But it's
Okay.
just that I can just use my device. But that is fine.
Okay.
I can practice in laptop and maybe just see in device.
Yeah, of course. But I would actually suggest that let's not practice during the class. I'll show you what I have to show, and then maybe later on you can practice.
Yes, yes. I mean, just if you say some things, I just try them out. At
Yeah.
least two, three important things.
Okay. Then let's not waste time. Uh, okay. I am just starting off with the last IPython notebook that I have. You may have already noticed what I did. I went on to this cell option and I say run all. What that does is that it's going to run all the commands which are there in this notebook. This is a very useful feature. Whenever you would like to continue with your work or continue with whatsoever analysis you are doing as part of a notebook, you can simply do this, that every code is executed and then you can start doing the analysis. So it will take some time. It is now in this position as I can see because everything else above has executed. Wherever there is a star is where it is executing. So usually during imports of libraries, it takes some time. Otherwise, it is not a problem. Then it has failed here because I don't have the stores.csv. So today I'll use something else. So that's why it's not there. So that's why you can see the rest of the cells are also not executed. So maybe what I will do, let me just put the file in there anyways, so that at least I can continue. I'll take another file and I will continue. Give me 1 minute. I'll just paste it over here and let me take some other file. And then I should be able to continue. Give me 1 minute. Okay. So I'll come back to my folder and I will paste this. Fine. Okay. And now I will go back to my sharing and resume share. I hope you can see it now. So I will run this line now. I will just place the file back and I can see our stores data. The stores data, if you remember yesterday, we were looking at this data. Maybe Saransh have missed it. You can watch the video that I've shared. So we are simply taking a CSV file that contains all the stores information of Walmart, and we are exploring this library known as Pandas. It is a very funny name, but it is very useful. So now I will also show you something else. Before we move ahead, there is one library which is part of Python, which we are going to use very frequently. So that library, I'll just write some comments over here and let me do one thing. Let me increase my zoom as well so that you all can see it. So I'll write very important, I'll say in quotes, operational library, right? It is not a data analysis library. It is an operational library in Python, which we very frequently use is OS. So this OS library is really, really very important. When we are doing any such analysis like this one, OS comes in handy. Example given, I would like to see, let's check the current directory. So what I do, OS get working directory. I hope this is not the command. Yeah, this should be CWD. Yeah. So this is currently my library where I am. You see, I've created a folder for the Telegram group, and here I have this 6th class, right? So this is my library. I can even change if I want to change the directory. I'm not going to do that, by the way, but I can change the directory. CHDIR should be the command by means of which I can change the directory, right? The reason why I am showing this to you is because in any library for that matter, depending on how good or how fast your laptop is today, my laptop is a bit slow, so it's going to take time. So you can simply put the name of the library, put a dot and do a tab. If you do a tab, you can see all the methods which are available in that, right? So you can see all the methods which is there. Okay, these are all the methods that we could do. So each and every method has some kind of a use. So if you would like to know what is the use of any method, I have already told you what to do. You have to use the question mark. Okay, so let me see if there is anything called list. List dir is there. So I would like to know what this is. I'll just say question mark and this, and it is going to show me that OS list dir path equal to none. I can choose not to give this path, and it returns a list containing the names of the files in the directory, right? So this is a very useful function. So in this way, every function can be found out by only making use of this. So let me just run this, and I'll be able to see that I have these files. So let's go through them. So this is a very important thing. I'll just quickly go through them. First of all, this file, IPYNB checkpoints. What is this file? On top of the notebook, you can see there's something written as unsaved changes. I'll just press save. Okay. We are not done with the session yet, but I'm pressing save. When I'm pressing save, it's going to save a copy of that file in the directory where we are. We are in this directory now. It's going to save a copy of the file with the latest changes that we have done, right? It has saved it now. How do I know it has saved it now? Because it has made a checkpoint. Until and unless I go to file and I do close and halt, it's going to keep making checkpoints, and it usually does an auto save. So this is a very nice feature, but you should not be relying on it. You should be from time to time saving the notebook. Always remember this: save the notebook. Just like you save your code file or script files or any ID which we are going to use later on, we are going to use some IDs as well. So in that case also, we usually save our code. In that way, you should always save your code. But even if you don't, by default, after a few seconds, after a few minutes, depending on the performance of your disk, of your RAM, uh, IPython is something that I'm going to talk about now. It is going to save your file, right? But don't always rely on that. Now, how does Python know that it has saved a file and there is such a checkpoint available? All that information is available inside this. So this, just a moment. I think Saransh has left. So I just admitted him once more. He's joining in. So, okay, he's here now. So IPYNB underscore checkpoints. This is not a file. This is a folder actually. So this folder contains all the saved IPython notebooks in the format in which they are. What I mean by that is I have many cells over here. As you can see, I've executed them. There are outputs. So that's all saved inside that directory here in this path. This is my head path, or this is my root path. And inside there, you will find a directory called IPYNB checkpoints. Inside these checkpoints, you will find copies of files like this: day-06-10.32020.ipynb. So .ipynb is the file extension. Now, why IPYNB? NB stands for notebook. PY stands for Python. Usually we end or we give the file extension of Python code as .py. Why this I is because this is interactive Python. We are interactively using commands of Python and we are trying to execute them. We are trying to see if they're working. We're trying to see if they're failing. We are trying to explore the functions which is there in different, let's say, functions into different, let's say, libraries and so on and so forth. That's why I call it interactive Python. And this is what Python calls it as well. So this is how it usually is named. Now, IPython is also a tool, a command line utility, which I had shown on the first day. I can share the recorded videos once more of the first day if you would want to revise. On the first day when we did the Python exercises, the very, very basic ones, when we started off with the Jupyter Notebook, we looked into IPython. IPython is just a shell where I can type interactive Python. Then why is this notebook has a term called Jupyter? Because Jupyter, you can say, is a newer version or a newer incarnation of IPython. IPython had a few limitations. Okay, IPython notebooks also had a few limitations, which are being beautifully covered by Jupyter. Example given, one of the main features of Jupyter, which I personally use in our organization where I'm actually working right now, is that Jupyter also provides a server kind of a facility where I'm 24/7 running a server of Jupyter notebooks. So people who are authorized to log in into the server can log in inside with their designated user agent password, and they can create notebooks like these. They can share them with each other, and they can play the notebooks as they want. So that's a very, very important feature which is added into Jupyter. There are a lot of others. You can go to Google, you can see them. The most important and most interesting is this. The second thing is this: if I go to file and I go to download as, if you see here, the options that I have are plenty. Just a moment. So here I see I can export this document as HTML. I can export this document as Markdown, as a notebook, as a PDF, as a script, and so on and so forth. We are going to see a few options out of these. Example given, I'll take a very, very common option. This is an option which I usually use when I'm sharing my analysis with whomsoever is asking me to do some analysis. Example, once a person asked that I am trying to ascertain the fact that I did some marketing campaign in the last year during the Christmas period. Is that really successful? So I did a lot of analysis on top of that, and I wanted to share that with him. he is emailing me, and that's why I need to reply back to his email. So I did my analysis. I put all the comments. I did it with a lot of visualizations, which we are going to do, by the way. Then I exported it as PDF, and then I give it to him. This may sometimes require an additional library to be installed on a laptop, but this is one of the things that I want to tell you, that you can easily export your IPython notebooks to other formats, which means if I am going to give my IPython notebook to Abhay, it is not necessarily a mandate, okay, for Abhay to have Anaconda installed or to be proficient of starting and using and running cells inside a Jupyter notebook, which he may or may not be aware of. But I can share my notebook as an HTML or a PDF, and he should be able to see it. Most probably, or maybe to give an example, what I'll do after this session is over, when I share the materials, I'm going to share this notebook as of this date as an HTML as well as a PDF. Hopefully that PDF export is going to work. If I have that library in place, I'll cross check, right? So that's the first thing I wanted to tell you. The second thing are the rest of the files. So we are going to continue with today's class with this file. Okay, this file is a bit bigger file, and I'm going to show you what this file is and what it contains. So let's import this file. So we know that to import the train.csv file using, we have a read CSV function. Okay, now before I really do that, I wanted to show you, sorry, I wanted to show you what all options are there under pd.read CSV. pd.read CSV, why is this? Because pd is how I have imported pandas. Pandas, I have not imported pandas directly. I have imported pandas as pd. So pd is the alias. So that's why I'm saying pd.read CSV. If I press an enter here, it's going to show me the help. Clearly, there are a lot of options, and I just wanted to quickly tell you about two options. Okay, two to three at least. First of all, when you do read CSV and your CSV is properly formatted with comma as the delimiter, and you have, let's say, all the headings mentioned for each and every columns and so on and so forth, everything goes fine. But there will be cases where this is not the situation. As you can see, there are a lot of options in here, and there are the parameters are also explained over here. So you can read through it if you want, but I'll just go through the most important and the most useful ones, because these are the ones which will help you solve problems. Example given: not all CSVs are actually comma separated value files. This is a very contradictory statement, I know, but when you work on real life examples, people will create CSV files. Even I have done that, and I'm being very honest that there was a very valid reason of doing that. I've created CSV files using a delimiter, which is not a comma, which is actually something else. Example given, let's say I have a file, and let's say that file contains data something like this. Okay, so it contains data something like, let's say I have ID of the employees in my company, then I have the name. Okay, and usually what happens is, in our company, we specify names of employees as last name comma first name. Okay, so if you look at the directory structure in our company, it is like, it is not a single word, or it is not usually a word into double quotes. It is usually last name and first name. But depending on how I have extracted this CSV, this is now going to be a problem, because I wanted two columns, now I have got three columns. So what do? I can either morph the data while downloading the data by putting double quotes over here. If I have the facility, I can do that. But if someone else has given me the data, I may find it very difficult in doing. So what I'll ask him to do instead, that my friend, don't use comma as your delimiter, use a semicolon. So that's what you can specify in form of the SCP parameter. SEP means the separator. So this is the separator which is there. Okay, now the second thing I wanted to show you is header. By default, the value of header is infer. Infer means inside the file, you will have lines like these. Let's say I have a file which says employee underscore ID, then, and then it is going to have, let's say, the column as employee, employee name, and then I'm going to have the rows, example 1 1 1 1 1, and then a semicolon, and then the first name and last name, and then another row which is, let's say, 22222, and then the last name and the first name, right? So what I mean by this is, if this is the format in which somebody has given me the CSV file, I'm really going to thank him for that. I'm really going to thank her for that, is because, just quickly check if there are no more participants. No, fine. I'm really going to thank that person, because that person has done one very important job for me. He has given the headers. If the headers were not there, I had to do a lot of questions and answers kind of a session to understand what these columns mean. Because as a newcomer, I may or may not understand what they are, right? So that's a very important thing. If that is done, brilliant. If that is not done, from time to time you may need to do that as well, right? Usually when we take exports out of database administrators forget to include the column names as part of an export. They usually turn the heading off, because it is very easy for them to format the output if they've turned the heading off, and in this way they'll only export you the data and not the headings. So that's when you will need to enter the headings, in which case you will have to enter the header here, right? So the header will be useful in that case, right? We will see what is there in this trend.csv. I've not seen the file, so I'll have to look at it. Then there is one more which I wanted to know, and that is, let me just find where it has gone. Okay, there is a very important parameter. I think I found it. Yes, encoding. Encoding is a very, very important thing. Encoding means that, let's say, this file over here, this CSV file is extracted out of a system which is running not a Windows operating system, but a Red Hat Linux operating system, or an Ubuntu operating system, or any other version of, it's a Linux operating system. Okay, or the opposite. So if I am importing, let's say, a data, I am playing on Windows right now, I am into a Windows OS, I am taking data from somebody, let's say I'm taking the data from Rohi. Rohi is using a MacBook. He has exported the data from MacBook, he has given me a CSV. Windows will be able to decipher that CSV and will be able to use it. But then if I do the opposite, I am extracting a CSV, giving it to Rahul, Rahul may find some errors. And the reason why he will find some errors is because Microsoft sometimes enters some rubbish values like these in the files. These are some kind of special characters which is introduced in each and every file at the various occasions unwantedly. So in this way, this will be very difficult for me to read that file, in which case I need to specify the encoding in which that data has been extracted. Now, encoding is not limited only to operating system, it is also limited to the lingua franca, or maybe the linguistic. Example given, I'm in Italy and I'm in France. There, the keyboards are also in France. Okay, if I go to China, my keyboards are also in Chinese. So their language, their keyboards, their input methods will be different for them as opposed to what it is for us. Because in India, maybe we are using keyboards which are made in the UK or in India or in the US, in which case there is a particular style in which our keyboard works while interacting with the computer. But it may not be so easy when it comes to China, right? When it comes to Japan, when it comes to Italy, because they prefer using their local language as opposed to the US English and UK English and so on and so forth. So that's when the encoding feature is really going to help. So I would like all of you, I will write this over here clearly. I will actually remove this. You can see that in the video. I'm going to write these three entries. First of all is this, then I'm going to write header, and then I'm going to write the encoding variable. Where is that variable? Encoding. Yes, I got it. Yes. Okay. I got the encoding variable. There is also another variable called skip blank lines and skip rows. I'm not going to look into this right now. I'm not going to tell you what this is, but I'm anyways going to write it over here. Skip rows is something which is also very, very important. I'll just write what this means. This is to define the separator of each line. Then I have this, which is to provide, if needed, a list of items, or I'll not say items, I'll say column names, okay, or feature names. Okay, I may have already told you that these two words, column and feature, this will be used interchangeably when we are doing data science. In data science, there is no database terminology which is usually used. Usually all the fields, all the columns which you see are usually known as features. They are the features of the data. They are featured inside the data. They are providing the features about the data which we are actually playing with. So that's why they are seldom called columns, they are called features. In coding, to convert Windows to Linux files or to handle special characters, etc. Okay. Skip rows. I'm not going to explain this. I'll leave it up to your curiosity to find out. I'll only paste a question over here. Find it out. Go to YouTube, go to Google and find this out. This is really going to help you if you don't have enough budget with you. This is a very, very serious kind of uh, a point or an issue, that if let's say you don't have the right amount of budget to buy a good laptop, you don't have a good system, you don't have a good environment where you have a lot of CPU, lot of RAM, how are you going to efficiently read the data using a pandas data frame? How what if I do not have a laptop with the good RAM? So this is the question. Okay, find the answer. Okay, if you have any doubts, please let me know. We have the group chat. Please paste it there into Telegram or you can mail me. So I would like you to find out what is skip rows and how are we going to use skip rows. But it's only going to be useful for you if you don't have a good laptop. Okay, if you have a laptop which has, let's say, 8 to 16 GB of RAM, you are done. You don't need any skip rows kind of thing unless and until you are working with very big data. So as part of our this journey, we are also going to look into big data analytics, in which case we may find a lot of huge amount of data which we need to analyze with. In that case, skip rows is going to come handy if I'm doing the analysis on my laptop. If I'm doing it on some server, then it will not be a problem. Right now, what I'm going to do, let me import this file and let's see what it is doing. See, somebody has already created the file in such a beautiful way that he has given the store, the department, the date, the weekly sales, or is holiday or not. Right, it has 421570 rows. These are the number of rows which I have and 5 columns. So I'll just save this inside variable called Walmart. Why I'm storing it in Walmart, I'll just tell you in 2 minutes. But first of all, let me do head 10. Okay, we saw already that using head, I can get the head or the top rows. Using tail, I can get the lower rows in the descending order on the, all the, or the last rows. I'm sorry, right? So the reason why I saved this in Walmart is because this CSV file, and you will at a very later stage understand what is the meaning of this name train.csv. When we do machine learning, we'll come to know what is the meaning of train. You will at many places find two kinds of CSV files. What is train.csv, other one is known as test.csv. Why is this train.csv and why is this test.csv is a very interesting aspect. I'm not going to cover it right now, it will simply confuse you. We will cover that at a later stage, but maybe quickly I can tell you what this means. So at any point in time, if I have a data set which is something like this, I am never ever going to do the analysis on the entire data set. I am never going to do any analysis on the entire data set. I may want to explore the data. I may want to do machine learning. I may want to solve specific questions and so on. I am never ever going to play with the entire data. What I'm going to do, I'm going to take a subset of the data. Why am I going to take a subset of the data is something which will be clear over a period of time, but I'll call this subset which I use as train. Okay, this is where I'm going to do all the training and all the learning. Either it is the training for me or it is the training for the machine learning algorithm which I'm going to use. You'll be more familiar with the terminologies as we go along. But as of now, please remember that I am never going to use the entire data. It will always be divided into two sets. There will be a ratio. I will tell you what is the usual ratio. I'm going to always use the trained data. That is why this is known as train.csv. Okay. The other part of the data is known as test.csv. And interestingly, as a data scientist, we may need to create this training and testing set sometimes. Okay. When I talk about the machine learning aspects, there we are going to talk about how we are going to create this. But as of now, I will tell you why we are creating this. If I am doing any conclusions, okay, any conclusions on this training data, then I need to validate whether my conclusion is correct or not. It is right. It is like reading a textbook and then appearing for an exam. If I don't appear for an exam, how do I come to know whether I've read or whether I've understood the concepts? That's the reason why I have a test data. This is the test data where I'm going to test all my assumptions. All my assumptions in statistical or data science terminology is otherwise known as hypothesis. So I'm going to test all my hypotheses, and we are going to look into these terms. Hence, don't worry. Please don't get confused if you're not able to understand the meaning of what is hypothesis and why we are testing it. These are really important terms which we are going to look into. So don't worry. But if I have any concept, so I am supremely confident of some concept, I practice the concept in train, and then I go for an exam where I'm going to validate the constants. Okay, whatsoever I have understood will be validated over the test set. Usually, if I have a data of 100 rows, if I have a data of 100 rows, I train the data on 70 rows and I test the data on 30 rows. This is the de facto standard. How is this train data created, or how is this test data created? We are going to talk about it. But as of now, I can only tell you that it is entirely based on some very, very definitive sampling technique. Remember this word, we are going to use that at a later stage. We are going to read about it. We are going to study what is sampling, what is a sampling technique, why it is useful, so on and so forth. But as of now, all I wanted to tell you, you will find a lot of data which is divided already for you into train.csv and test.csv, which is 70-30 kind of assumed 70-30 break of the entire data, provided it has 100 rows. 70 will be training, 30 will be testing. And on training, I'm going to do all my analysis and my machine learning and all the tasks that I am actually getting paid for. And then on the rest 30%, I will be validating how much I was correct or how much I was incorrect. In many cases, it may well be the fact that someone else is going to test my analysis. So I may not even have the test data. So this is how it is. So I'll just clear all the drawings and let me go back to this. In the meanwhile, what I'm going to do, let me just go back to all of you. I'll mute myself and I'll just wait if you have any questions. So but if you have any questions, please unmute and you can ask me. Okay, I will assume there are no questions. So let me quickly proceed and let me see what is going on over here. So I have a column which is store. I have a column which is DEPT. I have a column which is date. I have a weekly sales column. And I have whether there is a holiday or not. So this is some data. I don't know what this data means because I don't have any document as of now which you can see on the screen. So I should not do any assumptions about the data. This is a very important thing you need to remember. Never assume anything about any data set. If somebody is giving you a data or you are extracting any data, be 100% sure what these fields mean. Usually you create a definition language which is known as the data definition language. You create a document, clear cut, let's say detailed document, explaining each and every fields like store, DEPT, date, weekly sales, holiday, so on and so forth. And you also write down what are the unique values, why these values are so on and so forth. So you need some kind of a data which is going to explain what that data means. Let me see if I have that kind of data or no. Let me just pause the screen. Okay, good news. I have found a file which is called features.csv. So let me just see if I am able to see that file. As you can see, I have found a file called features.csv. Let me also import this file, and I'll say features is equal to pd.read csv, and inside the brackets I'm going to give this, and then I'm going to say features and print, right? So I am seeing a features file. Now, I expected this file to have details about the features because that is what we studied right earlier. I'm going to call the columns as the features. This is what I wrote earlier as well. So here I expected features.csv to tell me something about the features of that data. So maybe if I have done Walmart head 10, I got some data, and then I wanted to know about the columns. I should have known more about it from features.csv, but the file is named in such a way that it is actually not giving me any information about the columns of the first uh, data frame. It's actually giving features about stores. Example given, store number 1 on this date has a temperature of this, fuel price was something like this. I don't know what this markdown 1, markdown 2, markdown 3, markdown 4, but I don't know what these columns mean. So I need to find out what these columns are. So this data dictionary needs to be figured out, which I'm going to do, and then we are going to look at it. Okay, so as of now, let's ignore the data dictionary. We simply saw how we have imported two files, and let's go ahead with this Walmart data, and let's see if we can do some more analysis on this data, and if we are able to find anything hidden inside the data. What I'm going to do as part of, let me just do one thing. uh, yeah, so what I'm going to do is that I am going to go through something known as the operators. Okay, the operators that I was actually talking about, the operators which are going to help me select the data. So what I am going to do as of now is, let's say in this case, okay, something that we have already done earlier, something which we have done yesterday as well, we are just going to continue doing that because there are a few things that I need to tell you about it. Let's say I need data of Walmart only for store ID 32. Okay, somebody is asking me, can you please tell me the data which you have for store ID 32? So there is something that I wanted to show you. First of all, I can use a column to select a column like this. Okay, inside, just like a list. Okay, I'm passing a list of columns I want to select, right? So this is the data frame. This is the list of columns I want to select, and then I should be able to do head, and I will be able to see the data. Now I want to select the stores where store ID is equal to 32. I press enter and I see there is nothing. Okay, if I do, let's say 45, I see nothing. I don't know. I mean, when I printed the output, I saw there is a store 45. In this case, I can see there is a store called 45. But here I am not able to see. What if I put this inside a single quote? I'm still not able to see, right? The reason why I'm not able to see is because I have to use this. You cannot do assignment. You cannot do assignment inside a data frame in a column. You can only do conditional checks, and conditional checks are always like this. You cannot do a single equal to, you can do a double equal to, and the result will be like this. Again I see a problem, again I have a problem. You see, 45, I expected 45 to be the last store ID, but it is still saying false. What if I convert this to a string and I say something like this, and here I say that everything is true? Okay, there is something wrong over here. So the thing that I wanted to tell you here, first of all, this is one way to select the data. Second is this thing, if you're doing a comparison, always use double equal to. You cannot do single equal to, it is not going to result into anything at all. Okay, if you do something like this, you have actually done a blunder. Let me tell you what blunder you have done. Okay, if I do a single equal to, and then I do this, okay, sorry, I'll just do a head 10. Now see what I have done. If I use an assignment operator, it has actually imputed the value, right? So this is going to be a problem later on if you don't pay attention over here. It has updated the store IDs of all the stores being equal to 45. How do I correct this? Very, very simple way. Go back here, just load the data once more, and you have got the data back. If you see over here, now you have got the data. Now, before you even proceed with this, what you essentially should be doing is Walmart dot info. We have already seen the info command yesterday. Info is going to give the information about the data set. We have these many rows, these many columns. There is not even a single null value. As you can see, these values are matching with the number of rows, so there are no nulls. But I need to do some operations on store, which is an integer variable. That is the reason why I will simply copy this, or maybe I'll execute it over here as well. No, let's uh, let me put a comment, but with this command below, I will end up imputing the data. Don't do this usually, okay? If you have done so by mistake, what needs to be done? Re-import the data, okay? Then I'll come back over here and I'm going to say, I'll come back over here and I will say equal to 45. It is giving me false and false. The reason is very simple. It is an integer column. I should be doing something like this. The output is Boolean. In the rows where store is equal to 45, it is true. If it is not, it is false. So I just enclose this output inside the data frame itself. And what I see are the details of 9,637 rows with 5 columns for store ID 45. Okay. Now, let's say, again, I have got a question. You give answer to one, your clients might ask you 10 more questions. Be ready for that. So now your client is saying, also, I need data of Walmart. Yes, Arangs.
Why are you enclosing again within a Walmart? I mean, if you are doing
Yes.
Walmart,
Yeah.
so
Right. You have a very valid
yes,
question. So
I
let
mean,
me go back. If I only execute, okay, if I only execute this much part, this is going to return me an array of booleans. Okay, it is going to return me an array or a series of booleans, true or false, true or false. That's why I need to put this conditional check inside the data frame within a list or the brackets of a list. This is known as conditional checking inside a data frame. So inside that bracket, if I put a condition, that condition gets applied to the entire data frame. What I mean by that is on this data frame, Walmart, apply a condition, Walmart store is equal to 45.
okay, so wherever their Walmart store equals to 45, first it will return a Boolean value that is true or false.
Correct.
So you are saying that now within the data frame Walmart, find all the true values
Right,
for
right.
wherever
So
store is
within the
45.
data frame, find all the values where the check condition Walmart store is equal to 45 is true.
Okay, okay. Is
Right.
this
So
the only way in Python, Mohammed? So,
it is usually the only way.
to
It is usually the only way.
okay,
And there
okay,
are other ways as well, because sometimes, as we are going to see now, we are going to see something now that we will have more than one condition as well. In that case, this part is just going to get a little bit complicated. That's all. This is usually almost always the only way to extract the data. Okay.
okay, Mohammed.
I
Got
think
it.
I have answered. So let me progress now. First time the client asks, I need data of Walmart only for storage 32. Now he's saying also I need data of Walmart. For here, he can say there is a lot of, let's say, departments. There are department number 1 until department number 98. I need data for department ID being a 37, if at all that exists. So let me just simply add another value. It's very simple, right? I'll just add another value. So the column name is DPT. I'll add DPT, and here equal to I have to use. I'll use 37 and press enter. Unfortunately, it is giving me an error. The truth value of a series is ambiguous. Use AMT, A bool, A item, A any, or A all. I don't understand. Have I done anything wrong? Yes, I have done two things wrong. First of all, I have done this as wrong. And should not be used as and, it should be used as ampersand. Now let's see if the error is gone. No, the error is still there. Why is it still there? If you have more than one condition, you need to put each and every condition inside brackets, inside the single bracket. So that is what I am doing right now. If I press enter, I can see there is at least some output. There may or may not be any department equal to 37. That is the reason why the data frame did not return you any value. Let's say if I change this over to 98, it is going to return me the value. So there are 135 rows where I have information about store ID 45 and department ID 98 with some information. Right? So this is one variation. This is what we are going to very commonly use. This is a very, very important, let's say, variation where we are not using one but more than one. So if we are using more than one condition, so I'll just write it here. If we use more than one condition, then we condition, we need to make use of brackets as well as ampersand sign. Okay, ampersand sign is why, because ampersand is a logical operator to denote and. Okay, it is denoting an and operation. Okay, what if I need to do an or operation? Now the client has really got crazy. What he's saying, also I need the data for department ID 37. Instead, also के जगह पे he is saying or I need the data of Walmart for department ID 37, in which case this becomes an or and it becomes a pipe character, and then I give him the data. Now you can see there are a lot of other fields which are selected. Why? Either or has been selected. In this case, I have used pipe, and pipe is going to represent an or operation, right? So these are some of the operations that we are going to do. These are some of the operations which is applicable on almost all of the columns which we see over here. Okay, now you might be wondering why we are doing this. We are doing this only to do the exploration of the data. This is something that you will have to do every time you are playing around with the data set. Every time you are playing with the data, you need to explore the data thoroughly. You need to understand the data very, very thoroughly. You need to understand what this data means, what this data is all about, what all rows are there in the data, so on and so forth. If you do not understand what this data is, you will never be able to do proper analysis on the data. So profiling the data, in other words, is very, very important, which you need to do for each and every case, irrespective you have a very simple question or you have a very difficult question to answer. It doesn't matter. You need to explore the data very, very well. Right? Example given, I now need to see, let's say again, a client has come which says, I need to know the cases where weekly sales is greater than or equal to, I don't know, 40K. Okay. So what I need to do, Walmart, where I have weekly sales is greater than or equal to 40,000. Okay, if I press and enter, I can see I've got the output, but I have gotten bored. I am now bored of using this kind of a syntax always. I'm going to show you a different syntax now. Here, the column name has no spaces within it. If there are no spaces within it, there is one more way in which you can do, and that is to use the dot operator as well. The output is going to be the same. if the column name does not have any spaces. Example given, I go back over here. In this case, I can simply replace this with a dot and remove this. And even in this case, my output will work. So you see, I've called one column as dot, one column as a list of column. It is still going to work. Okay. So this is something you can remember. But now I've got the cases in a Boolean format. I need to format it like this. So I again do things like this. There are 46,898 rows in which I have got weekly sales, which is more than 40,000. Now, what if the user again says 40,000 and I want to know the distinct, okay, the distinct, or let's say the unique store IDs. Okay, you answer one question for a client, the client is going to ask you another question. What do you do in this case? You simply write store, I think is the name of the column, so I just write store, and the output I get is the store. Here I can use a very important function called value counts, should be, and I will get the list of value counts. Okay, what is this value counts doing? Dot value underscore counts function uh, will return a group by on a univariate or a single variable. Okay, so I have selected a single variable and I have given the value counts, and here I could clearly see that I am actually getting the output in a descending order of all the store IDs and the count of those, or the occurrences of store ID and the count of that store where weekly sales is more than 40,000, in which case the answer is very simple. The top 5 stores where weekly sales is more than 40,000 are these: store number 4, store number 10, store number 20, store number 13, store number 14. Right? These are the top 5. Can I do something on top of this? The answer is yes. Let me see what is the type of this. Okay, this type is going to be series. This is a data structure we have not seen because this is a data structure which is inherent to Python. We may or may not use it in daily purposes. That is the reason why we never saw what is a series, how is it used, so on and so forth. But a series is how internally the data is represented. Can I do something on top of this? Yes, I can again say pd.data frame, and I can convert this data into a data frame. The only problem in here is I cannot create 2 columns with store ID and the numbers directly. I need to use some techniques here. Okay, because this output of 2 columns which you are seeing as 2 columns.
Uh,
Yeah.
yeah, sorry to disturb. So in Python, whenever we are doing some kind of grouping,
Hmm.
so it is always the type is always series
No,
by default.
no. No, it may not be a series. We are not really doing a grouping. We are taking the count of values over here. So we are simply doing kind of, let's say, a database query of select employee ID comma count star from EMP table. So that's what all we are doing. And then at the end of the query, you obviously need to write group by employee ID, and that's exactly what it is not doing over here. It is not really doing a grouping. It is just finding out the histogram. Histogram is something which we are going to look at a later stage. You can call that a frequency table as well. So store ID number 4 occurs 2622 times inside the data set. So that's what it is doing. Grouping is something a bit more advanced, and grouping results not into series, but into arrays or into matrices of data, which we are going to do, but not now. We're going to do it at later stage. Just wanted to show you what kind of things which we can do initially. Grouping is another operation which does not always necessarily result into a series. Okay, but value counts always is going to result into series because you are using value counts on top of a single variable, right? Can I do it on a multiple variable?
Got it.
Let's see. See, if I do it on a multiple variable, it is actually giving me an error. Okay, key error. Now, can I solve this? The answer may be yes. Let's see if I can put double brackets over here and see what it does. The answer is no. Why is this so? Because now this guy, okay, this the output of this, if I take this and if I put it over here and I do an output, this is actually a data frame. The type of this is actually a data frame. You see, this is actually a data frame. But earlier what I had is I had only store. So let me remove this. Let me also remove the DEPT thing that I have added extra. Let me take this line and let me go to a new line and say type of this. This is actually a series. That's the reason why, because we selected one column, that selection of one column is resulting into a series. Okay, this is also another answer to your question here, Sarang. So if we are selecting conditionally or unconditionally one column out of a data frame, it is almost always a series. Example given, type, and I'll say Walmart, and I'll say date. Date is a column. You see, it has selected it as series. It is not selecting it as list. I can convert it into list, and then it is going to show that to me as a list. Okay, I can convert that into a list using the function called list. Okay, so the list function is used to convert data from its original data type, which was a series, into a list, right? But usually if I select a column, when I select a column conditionally or unconditionally, what I mean by that is, here I've used a condition, right? Weekly sales is greater than or equal to 40,000. So this is a conditional select. If I do unconditionally also, the output is almost always a series. Why I'm saying almost always is because depending on the environment, depending on the software that you are using, depending on the version, depending on a lot of other things, especially related to the software, the series may not be there. In some earlier obsolete versions of Python, maybe it's not a series. In future versions, it may get converted from series into a list. We don't know. So almost always select a column, it's a list. On top of that, you do any operations, it is also a series. I'm sorry. So you select a column, it's a series. You do an operation, that's also series. But if you select multiple columns like this, when we select multiple columns from a data set, okay, conditionally or unconditionally, I'll just paste it over here. The output is always, this is not almost, this is always a data frame. Okay, so I select multiple columns, it will always be a data frame. This is also another way in which I subset a data frame. If I have a data frame with 50 columns and I need to select only 3 columns, I can simply put that in a list format like this, which is also known as a double list. Because I'm selecting multiple columns, I can put it inside double list features like this. Okay, I think we have done some part now. Maybe we will stop over here for today. Okay, if you have any questions, please let me know.
No questions.
Okay, I'll assume there are no questions. Then what I will do, let me close the session. I'll stop the sharing. Let me close the session as well. Okay, let me just go back to my notebook. Let me save it and let me exit from there. And I will also export it as HTML and I'll also be sending it over to you as I have said. So I think that's all for today. Let's meet on Monday. Have a good weekend. Thanks all. Thank you. Thank you.
Yeah, thank you. Bye.